Lesson 10, Angles, Arcs, and Radii. Our aim today is let's analyze the relationships between central angles, arc length, and radii. Alright, so 10.1. Han and Tyler are each completing the same set of tasks on an online homework site. Han is using his smartphone, and Tyler is using his tablet computer. Their progress is indicated by circular bars shown in the image. The shaded arc represents the tasks that they have been completed. When the full circumference of the circle is shaded, they will be finished with all the tasks. So here we've got Han's loading progress and Tyler's loading progress. Tyler says, the arc length on my progress bar measures 4.75 centimeters. The arc length on Han's progress bar measures 2.25 centimeters. So I've completed more tasks than Han has. Do you agree with Tyler? Why or why not? So take a second and answer that question. Doesn't have to be correct. Just think about, is there enough information in the problem to prove that Tyler has completed more of the tasks than Han has? Okay, so hopefully you agreed that it's not enough information, right? There's some more stuff that we need to know. First off, which part of the arc did they measure? Are they measuring this inner arc here, or are they measuring the outer arc? It doesn't really matter which one they choose. It just needs to be the same for each diagram. If you measure the inner arc here, measure the inner arc for Tyler. Outer arc for Han, outer arc for Tyler. So that's one thing I would really want to know before I answer this question. Another thing I need to know is, what is the total distance for 100% completion? If Han has 2.25 centimeters, but his total circumference is 2.26, right? Then he only has 0.01 centimeters left over. So I need to know the total circumference. So let's say we know that Han's total circumference is x and Tyler's total circumference is y. Why would that be beneficial? What could I do with those two numbers? Well, we'd want to create proportions and compare them. So if Han's progress is 2.25 centimeters, I want to see, out of those 2.25 centimeters, out of the total x, he's gone 2.25, what percentage of the entire circle has he gone around? We could do the same thing with Tyler. If I know I've gone 4.75 out of y total centimeters, that would give me the proportion or the percentage completed. Really, what both of these two proportions are calculating, which would have been just an easier answer to all this, is the central angle created that creates this arc, right? Let's take a compass out. So I'm just estimating about, where this compass would be centered to make a circle like this. And we have to realize that if I'm going all the way around, right, 100% completion, that's 360 degrees. So degree measure is an exact correlation to how much has been completed, right? 360 degrees would mean the entire task has been completed. 90 degrees would mean a quarter, 180 would be half. So if I know my central angle here, it's exactly equivalent to percentage complete. So if I knew that, that would really help me right off the bat. I would be able to find the central angle, though, if I knew the length of the arc and the radius. So if you remember, our formula for arc length is L equal to theta over 360 times 2 pi r. If we knew what the radius was and the length, that would knock out two variables. We would just be left with theta, so we could solve for that, which would be the central angle, and will tell us exactly what percentage had been completed or how much had been completed. All right, that's all for 10.1.